Hi everyone, welcome to Vijay Datta chemistry classes. This is Purnima ma'am. So today we are going to start with a calculation of some compounds oxidation numbers. So let us see how to calculate. Today see generally we can calculate the oxidation number. We can assume the unknown oxidation number one as the x and all. So here some exemptional oxidation states, that is nothing but if we calculate we'll get one oxidation number, but actually it shows another oxidation number. Let us try like that molecules. Okay, see here the first one is chromium peroxide. First one is chromium pentoxide. So its structure is CrO5. If you calculate it generally, you will get chromium, you will assume as X plus oxygen is minus 2 into 5. Then it shows plus 10. That is nothing but X is equal to plus 10. Chromium oxidation state is 10. But actually we have a rule that it cannot have a highest oxidation state is plus 8 only. It never exceeds the plus 8 oxidation number, but here it is showing plus 10. In the options also there will be plus 10. So what is the problem with this? Yeah, while in the compound oxygen is present, we have to be careful with that. Either oxygen is attached to that metal either in oxide state or in peroxide state. Or in peroxide state we have to check. See here, all the chrome oxides you have taken in minus 2, but you are getting plus 10, but maximum oxidation state is plus 8 only. Then what we have to see? When oxygen is attached in the oxide is nothing but double bond O like, then its oxidation state is minus 2. If oxygen is in peroxide linkage, then that peroxide linkage is nothing but this one, oxygen attached with single bond, then each oxygen shows minus 1 oxidation state. Even though here superoxides also there. Superoxides oxidation state is minus 1 by 2. Generally it is potassium only forms superoxides. From the top to bottom is considered either the reactivity is increasing, potassium forms oxides, peroxides and superoxides. If it is forming the oxides is nothing but see here K2O, it is an oxide. K2O2, it is a peroxide. KO2 is the superoxide like. It is oxide because see here, I'll calculate for K2O, K2O2 and KO2. Potassium is plus 1. We want to know oxygen's oxidation state, right? So, I'll take here oxygen I want to know. Oxygen's oxidation state. So potassium is plus 1. Plus 1 into how many are there? 2 are there. Plus x equal to 0. Then x is equal to minus 2. So it is in oxide linkage. So this is called potassium oxide we can say. Whereas come to the K2O2. Plus 1 into 2 plus 2x equal to 0. Then 2x is equals to minus 2. If this minus 2 comes this side, then x is equals to minus 1. So in the peroxide linkage, oxygen shows minus 1 oxidation state. What about superoxide? Superoxide is called KO2, right? So K is plus 1 plus oxygen's 2, each one is x which is equal to 0. Then 2x equals to minus 1, x equals to minus 1 by 2. So in the superoxides, oxygen is showing minus 1 by 2 oxidation state. So you have to check either the oxygen is in peroxide linkage, superoxide linkage or in oxide linkage like. See here CrO5. If you write the structure you will understand. Chromium, double bond O, total 5 oxygens. Maximum oxidation state shown by chromium is plus 6 only. If you take all oxygens are double bonds like this, then see chromium is showing how much it is extends its oxidation state. So it is not the structure. So what is the correct structure? Chromium. The oxygens are in peroxide linkage in the chromium. This is the reason. This is chromium directly attached with double bond. So it is oxide linkage. So it shows the minus 2 oxidation state over here. Here it is showing -2 oxidation state. Whereas come to here, they are in peroxide linkage, so each oxygen shows -1, -1. Here also it is -1 and -1. Chromium we don't know, so we will take X. Now come and calculate X plus 1 oxygen is in -2. Remaining 4 oxygens are in -1 linkage. Then X minus 2 minus 4 equal to 0. Then X equal to plus 6 means chromium oxidation state in the here it is plus 6. That is correct, not plus 10. Now plus 6 it is chromium, it shows oxidation state is plus 6 only. So in the CrO5 the chromium's oxidation state is plus 6. The shape of chromium pentoxide is nothing but called, this is a chromium peroxide ma. Actually 5 oxides are there, but not all are in oxide linkage, so we can take it is as a chromium peroxide like also, chromium peroxide CrO5. So here chromium's oxidation state is plus 6. The structure is called butterfly structure. CrO5 structure is called butterfly structure. This is one exemptional case while calculating the oxidation states. Next come to the Marshall acid and Carros acids. What is that Marshall acid and Carros acid? What is its names? Let us see. Those two also have some exemption. Next example I am taking peroxy disulfuric acid. Peroxy disulfuric acid. It is also known as Marshall acid. It is also known as Marshall acid. What is its structure? Let us see. H2S2O8. What is its molecular formula? H2S2O8. So they given like this, they asked sulfur's oxidation state. So as usual, you will calculate that 2 into 1 plus 2 into x plus each oxygen is -2. So -2 into 8 which is equals to 0. Then 2 plus 2x minus 16 equal to 0. Then 2x minus 14 equal to 0. Then 2x is equals to 14. Then x is showing the plus 7 oxidation state. Right? But actually, the oxidation state of sulfur shows plus 6. As sulfur belongs to the sixth group element, how come sulfur shows the 7? Because we have a rule that the element never increase oxidation state by its group number. Either its group number or below its group number, never exceeds its group number. As sulfur belongs to the sixth group, how can it shows the 17th? Means 7 as its oxidation state. So here also it is clear that oxygens are not all are in oxide linkage, some are in peroxide linkage. If you write the H2S2O8 structure, then you will understand easily. See here, two sulfurs are there, two sulfurs. Each sulfur should have 6 bonds. So two oxygens I am taking as peroxide linkage between SO. Then double bond O, double bond O, double bond O, double bond O. See here 1, 2, 3, 4, 5. Sulfur has the 5 bonds. Actually, it can have 6 bonds and hydrogens also there. So I'll go like this OH. Even here also OH. So if you understand, each sulfur is showing plus 6 oxidation state. Means it is having 6. So it is -1. So it is -1 oxidation state. Here it is also -1. These oxygens are -2 because they are double bonded linked. -2. And again oxide is nothing but -1 and it is also -1. If you calculate for this sulfur, -2, -2, -1, -1 for this sulfur, then X is equals to. Otherwise you can take also overall. Overall sulfur shows +2 means each sulfur shows the plus 6 oxidation state. -2, -2, -4, -5, -6. This X is surrounded with -6, that is nothing but +6. This sulfur is also surrounded with -6, so it comes equal to, then it is +6. So each sulfur shows its +6 oxidation state. So its structure is very, very, very important. Okay. Its structure is very, very, very important overall here. Okay, guys, like this, we have some exemptional case you can take even for the Carros acid also. Carros acid, NH3, NHE4 like that, and CaOCl2 means bleaching powder. Like this, also we have some exemptional cases in the calculating the oxidation number. So just what you have to check this one. And if you have any doubt, suppose you don't know how many peroxides and oxide linkages are there, H2SO8 or H2SO5 like they have given, while calculating how much you are getting, 2 into 1 plus x plus minus 2 into 5 equal to 0. Then 2 plus x minus 10 equal to 0. Then x equals to plus 8. But according to the oxidation state, but you don't know the H2SO5 structure, then do one thing. What is that you know? What is the highest oxidation state can shown by the sulfur? Plus 6 only, no? So you blindly go for the plus 6 oxidation state. You can fix that without knowing the structure, anything you don't know. Then simply what we have to do, you have to go, you got plus 8, but you know one point, what is that oxidation number never exceeds its group number. Sulfur is a sixth group number, but it is showing plus 8, it is wrong. Then what is its structure? Then go blindly with the highest oxidation state shown by that element, sulfur plus 6. So blindly you can go with the plus 6, H2SO5. Sulfur oxidation state can be the plus 5, like we can. Okay, so these are the some shortcuts in the oxidation states and calculating the oxidation number, guys. Okay. In the next video, I want to go with the types of reactions and what is thing. Please do watch my videos and search Vijay Datta chemistry classes, and please do watch my videos and subscribe, share, download the videos. It helps. If you're with your encouragement, I can do the more. I want to ready to explain each and every concept, not even logics I'm explaining the complete concept. Any doubt you have that concept, I am ready. Complete concept, I am ready to explain. And also, from the reduced CBSE portion, I want to take one chapter. I want to complete that within 3 or 4 videos like that. I am planning. So please do encourage and please subscribe to my channel. Okay, thank you so much.